Hello everyone, FunshineX here. Welcome back to Feed the Beast, Unleashed in Space. Today we will be doing some oxygen. We're going to power up our base so it's all filled with oxygen. We can breathe in here, and hopefully it all works great. In between episodes, I went ahead and wired a little bit. Got us all kind of prepared. So let's go down in here. I showed you this tunnel, but now I've got it all wired with some RedNet cable, or whatever cable this is, and some oxygen, and then I put a couple oxygen bubble distributors here. These guys put out a bubble that's 18 in diameter. Maybe it's 19. I don't know, it's 18 or 19. And it's like a circle, so you can think 9 by 9 by 9 around it. So I had to use quite a few of them. You can see they're all over the place. Did I not center those ones? No. Oh, yeah, they're centered. They just look weird. Okay. So those are there, and then we have a couple more down here. Let's see. Down that direction. Oh, you can probably see them better this way. So the oxygen cable comes there. There's a guy here, and then there's one over here, and one over here. So I've put down, let's see, I started with 13. I've put down 9 of them so far. 13 is the number that I figured during testing that you can support using 20 oxygen collectors at 100%. So if you look at each of these guys, they're at 100% oxygen. And because of all the wheat down there. So 20 of these guys can support 13 bubble distributors. So let's go ahead and hook these up. Let's go ahead and give it power. Go ahead and give it oxygen. And we should see some bubbles immediately forming over here. So let's go look. Alright, yep, I'm seeing some bubbles. It's growing. Looks like it didn't quite cover the whole area, but that's alright. I mean, when am I standing in this corner? You know, not very often. It looks like we got all the way here. Looks like... oh, we got a tiny section here that looks like it's not covered. So, that's alright. I think that's good. This is not covered, so we might want to put one in here. I don't know. Probably don't need one. Don't need one there, because if I'm going into there, then I'm wearing oxygen, right? Let's see. Oh, this area. No, it's got to have one. It's kind of hard to tell sometimes because you see the edge of one and the edge of this one, but you're actually in one because the edge of it is over here. So it's a little bit difficult to tell, especially look how many overlapping here. There's like 1, 2, 3, 4, 5 different bubbles going on. Alright, so here's a problem. We missed this whole area. No? Here, this will tell us real easy. Okay, we're good here. This is invalid. So we need to put some oxygen down that way, of course. I never even routed any pipes down there, so. And this whole area is good. Got oxygen here, all the way into here. Cool. So these are coming from up there, so it's getting down here. Enchanting room. Oh, part of the enchanting room is not covered, but yeah, most of it is. Whoa, this whole hallway. It's gonna need something. Same thing with this one, I assume. And then, yeah, these rooms don't have anything at all. Okay. That's pretty good coverage. This hallway doesn't have anything. Let's go check the upstairs. And I think what I'm going to do is I'm going to still wear my oxygen gear, but basically this will just mean I won't have to recharge it very often. So if I go into a part of my base that's not covered, it'll be fine. Oh, it looks like we got all the way out of here. Perfect. How does it look? Do you see the bubbles? That's interesting. I don't know if I like it, honestly. If it just filled into like the air and didn't go through walls, I think I might like it better. You know, it's just like, instead of doing a sphere, it just said I'll fill in like 100 air cubes, and it would just start growing from, you know, spiraling out, trying to fill as much area as possible. Actually, technically, it should fill the entire area, and it just should be percentage based. Really, you know. But oh well, we're not going for realism. And then out here, I don't have anything. So one place I do really need to run it, I guess, would be the mob hallway and then the animal hallway. If we put villagers here, animals, whatever we put down this way. This is definitely going to have oxygen, because this sealer is just not good enough. The cow's still alive, because I just haven't gone in that room. But, okay, I think I may add to it as we go, but I think that's good enough for oxygen. It's not really... Sorry, it was kind of a anticlimactic. But yeah, we've got these bubbles, and who knows, I might even turn them off. I'm not sure. Okay, so let's take that off. If you guys have any suggestions on making it cooler, let me know. But for now, I'm just going to go ahead and say that's done. Put cool doors on the list here, because I want to have actual doors to my base. Probably just do some drawbridge doors with some player detectors, so they kind of open as I get close. I think that'll be next episode. Entrance all armors are still doing. Space villagers and moon buggy. I'd like to do this together, so I'll grab a moon buggy, and we're gonna drive around the moon looking for some villagers. And then solar power. I just made 32 more solars. So let's go ahead and grab those. Do we have LV? Yeah, I need 4 of these. Okay. And we'll go ahead and craft those up. And that should be 8 total low voltage arrays. I moved them. Oh, I gotta show you this. Yeah. So this was not generating enough force, whatever this stuff is called. Let's see. He'll tell me in a minute. Fortron. We were running out, so I added more. So we're now up to 10, 8. I don't know. Yeah, 10 of them. And now they're all working good. This thing is staying completely full. And this, yeah, we're using all this. No problems with the drives, the energy cells staying full either. I am running through a ton of force logs, though. Let's go look at that. Let's see. I have 0 force logs. Oh, that's not good. And I think what's happening is my squeezers are burning them so fast. It doesn't look like we're using it, but look, we've got 24%. So I don't need a whole stack of force logs. That doesn't really matter. I just need to know that that number doesn't go down. It should either always be going up or steady. So these are now out of force logs. 10. Yeah. So they're going to get a little bit as we go, and I don't really need 4 of them anymore, but I'll keep them there since they're... doesn't matter. So we'll keep a watch on it, and we'll see if it goes up or down. If it starts going down, that either means I need another source of power, more solar or something like that, or I need bigger tree farm. It just means these are running too much. Okay, so next thing I want to do, I want to implement something that's going to make our computer system look a lot better, and that's going to be called Open Peripherals. Basically, the mod Open Peripherals allows computers to interact with just a ton of blocks. I don't know how many or which ones are included or excluded, but redstone energy cells work great. So what we're going to do is let's go in here and get some computer craft stuff going. So that'll appease a lot of you guys that have been wanting to see more computer craft. Need an @ in there. Okay. So what we can do is we can put these wired modems on top, or connected to a redstone energy cell, and then wire it with the networking cable to a computer, and we'll be able to read all those energy cells. So I would like to get a modem, and I'm going to need 8 of these. They're really easy to build. So that's 8 of those. And then a ton of this networking cable, which is also simple to build. Let's get a whole stack. No. Stacks and 6. Alright, 60 is probably good enough. So let's go ahead and disconnect. Alright, I'm just going to... These aren't labeled, but the program's on paste bin if I need it. Okay, so what we're going to do, we're going to jump down here. No, can't get down there from here. Let's go down this one. And we're going to go ahead and attach the modems to the bottom here, so I've got plenty of room. Now basically what this will do is this will treat the energy cell like it's a peripheral. And it has different methods, and we'll see those in a minute. But go ahead and attach networking cable to all 4. And then we'll go ahead and just make them in a little loop here. Oops, where did I just put that one? Where did you go? Oh, right there. Oh, come on. There it goes. Can't break them with your hand. Alright, which one's missing one? Right here. There we go. Okay. And then we'll just go ahead and run it up right here. Perfect. Okay. Now one thing about these is you got to turn them all on. You got to connect them to the modem. So if you just right click, it's going to say redstone cell 0 connected. And then we'll do this one. This will be number 1. This will be number 2. And this will be number 3. Perfect. Okay. Go up here. And we'll go ahead and plop our computer. Did I want to put it in the back? No, right here's fine. Alright, so then we just go ahead and maybe I even want to bring it up one. So let's put another guy there. And the computer right here. I've got to put a modem attached to him as well. This looks like I needed more than I had. Do that. And there. Alright, now they are all connected and they're all peripherals. Perfect. Let's do a couple things. Can I tell you not to connect? No. I need an Omni wrench. I've been wanting one for a long time. Do I have one in my bag? I don't think so. Okay. Omni wrench. I doubt I have cyan wool. I have red and white. Perfect. Ah, darn it. Come on. We can get there. Cyan. Okay. Now give me this Omni wrench. Why is this made with wool? That makes no sense. Just because it's kind of a bluish wrench? I don't know. It's wrapped in wool. Okay, you stop connecting. Perfect. You are perfect. Okay, and we can actually get rid of this one. And all, what I need to do is now connect this all the way around. How am I going to do that? Maybe do it at the top? Because what I'm going to do is I'm going to have a white, an orange, a yellow, magenta, purple, green, you know, all the way around, and then I can control all 8 of the banks with just one computer. So where would be the best way? I think... Alright, let's not worry about that for now. But he should be able to read all of them. So let me terminate you. And let's go edit startup. Actually, delete startup. Rename. Start backup. Okay, so now it has no startup. What does Open P do? Oh, the directories. Interesting. I'll have to find out what programs are in there. But anyway, let's do edit startup. to create a new program. And let me go ahead and just write this off camera real quick, and then I'll go ahead and explain it. I'll be right back, guys. Okay, guys, I'm back. We have the computer all programmed and ready to go. I've added the second modem here that goes all the way up to the other 4 cells, and I had to move it back one because I wanted 2 inputs into each cell, because they can take 100 megajoules per tick, but it's possible that this bank might put out 200, so I'd like to go ahead and capture all of that just in case the top one is full. So that can go ahead and capture all 200, so all of those are set that way. I moved my tesseract back there. That should... I don't know, I might put it in a different place. I'm not using it at all right now. Yeah, let's just get rid of it for now. Put it somewhere else. Okay, so let's see the code. Or let's see the output. So you can see each cell, it's getting a nice little bar graph of how far it has charged. This 0 here means that it's turned off. It'll be a 1 if it's turned on. And then I've got the percentage that it's full. So these two are 100%, this one's 67. And I've set my bounds at 50 and 90. So basically when they go below 50, they should turn on. And when they go above 90, they should turn off. So I think that... I haven't really tested fully to make sure it's all working, but they're all off right now, which is supposed to be what's happening. Let's go ahead and look at the code. Yeah. Okay, so it's a little bit difficult to see because it's so long, but basically I define the peripheral for each cell, and you do peripheral.wrap, and then you pass it that string that it gave you when you attached the modem and turned it on. So it was redstone energy cell 0 through 7. So that's pretty easy to wrap peripheral. And then I've got a current state. I initialize them all to 0 when the program starts. That's for each peripheral in a table. And then I go ahead and get providers. I got a function here that I can use to get providers. I'm going to be doing this a lot because every time you want to update, this is basically telling you to say, or telling the program to say, go out to the cell 0 peripheral and get its latest stats. Just go ahead and execute this get power provider. We'll get all of its stats. And I assign that to cell 0, and then I do the same for all the 7 cells. So I can call that function whenever I need to go output, get the output. I have a write bar graph, and that's basically displays the graph that you see. It takes the cell number value, it takes the current value, how full it is, and then the state, whether it's on or off, and then it just writes out, the cell, 0, and then the left bracket. And then here's a little clever thing I did for a bar graph is basically I get the current width and height of the cursor position, and then I go ahead and write out 20 periods, which is string.repeat. That's what REP means. It means repeat this character, this string for this many things. So I write out 20 periods, then I write out a closing bracket, and then I write out the state after 2 spaces, and then I write out the floor of the value just so it rounds it a little bit for me. Okay, so that's where it writes there, but that would just provide me with a blank graph. Well, since I stored where the cursor position was before I wrote this, I can now set it back to where it was, and then I write out string.repeat with a star for the value divided by 5. So if it's 100, it would be 20. It would give me 20 stars, and it would overwrite all the periods. If it's only 10, it would give me 2 stars and only write 2 of the periods. So that gives you a really nice bar graph, really simple. Okay? And then I've got write status that clears the monitor, and then this is what actually writes out to the bundled cable. Oops, never mind, sorry, this is what it writes out the status of all the things. So it goes through each cell, sets the cursor position for each row, basically, and then passes to that bar graph function the values that are needed. The values that you get from the energy provider, one of them is energy stored, and the other one is max energy stored. So I can just divide them by each other, multiply by 100, that'll give me a percent, and then the current state will give me whether it's turned on or off. So do that 8 times, and then here's where I actually set the output. Current colors is just an integer. It's set to 0, initialized. And I say, well, if the first cell is energy stored divided by its max energy stored times 100 is less than 50, I mean it's under 50% full, then I'll set the state to 1. else if, so don't just do an else, because that would be if it's less than 50, turn it on. If it's greater than 50, turn it off, and I don't want to do that. So I would do else if it's the percent is greater than 90, then turn it off. So this will basically give me this value where if it dips below 50, turns it on, and then it stays on until it gets greater than 90. So I get a nice, it runs for a nice long period, it has time to warm up, or anything like that. And so that works. So I do that 8 times to set the current state of every engine, or every color, sorry. And then I go here and I set current colors equal, and I multiply each one. So current state 1 is the white, so the bank of engines on white is the first cell, and then current state 2, which is the second cell, is attached to the pink engines, and I do that for all the colors, so yellow, magenta, everything like that. So basically it says, well, if the statement is on, if current state 1 is on, meaning cell 0 needs to be on, then I multiply that 1 by colors white, and it'll give me the white value. If it's off, it's 0, then it'll blank out the white value. Whatever. It works. And then I set the bundled output equal to the current colors. So bundled output, all it does is you just add the colors together. It's just an integer. So colors.white is like 1, colors.yellow is 2, colors, it's like 4. I don't know. I think it's bitwise. I'm not entirely sure. But yeah, so you just add them all together and you set the bundled output. And then I'll set the appropriate colors, and then we have an infinite loop here that gets the providers, writes out the status, sets the output, sleeps 2 seconds, and does it all again. Pretty simple. I'll put the code in the description if you want it. So let's go ahead and exit it. Or let's save it because I think I made some changes. Control, oops, and let's just reboot the computer. There it goes. All right, so this one now is below 32, so it's turned on. 45 turned on. So quite a few of them turned on. You can see a lot of the upper ones, which are the even, no wait, 5 and 7, that would be upstairs. 0 and 3 would be downstairs. But they don't use power evenly. You can see that. Some of them, like cell 4, it never gets used. I don't know why. But there she goes. Turn it on. And I think as soon as one of these gets to 90, it will turn off. Anything happening? Come on. I think these ones are always, going to be on for a long time. So that's just, it seems like the ones that it drains from the most. Just happens to work that way. I think it's random. I don't know. But, so homework for you guys, not necessarily homework, but if you guys want a challenge, you've got these values in my computer, basically the current value, the percentage it is full, whether the engine is on or off, and which bank of engine it is, 0 through 7. Those are your data points that you have available to you. And I'm going to go ahead and put a color monitor, which we can go and build right here. And I would like the coolest display. We're going to hook it up with a modem, so it'll be easy to display to from that same computer. And I want the coolest display that just at a glance, whoops, will tell me what's on, what's off, what percentage it is. So use things like maybe red, yellow, green if it's in the, under 50, or if it's in between 50 or 90, or if it's over 90. Maybe, some color coding the engines. So you've got cell 0 is white, cell 4 is orange. You can look at the code and see this pretty easy, but cell 1 is magenta, cell 5 is light blue, oh wait, no, it goes the other way. Sorry. 1 is white, 2 is pink, 3 is yellow, 4 is magenta, 5 is orange, 6 is gray, 7 is lime, and 8 is light blue. It would have been nice if I did those in the right order, but I had already set all the colors, and then I didn't want to change it. So, yeah. Anyone that makes me a cool monitor output, I'm going to try myself, but if someone can make cooler the one than I can, I'm going to go ahead and rename Little Funshine after you. So you'll also want to send me your in-game name along with the code, and he will be your skin. So right now he's a chicken, but if I feed him some bread, he turns back into little Funshine. If I whack him with a stick, I can set his name, and if I whack him with something else, I think it's... I don't remember what it is. I'll have to look it up again. I can change his skin. So that's the plan. Whoever gives me the coolest monitor output will become Little Funshine, or become my sidekick for a couple episodes. Until the next challenge, basically. So let's get those golden monitors done. Advanced monitors. Should have plenty of gold for this. Let's get... let's do like a 3x4 maybe. So I need 12 of them. We'll see how this looks. Maybe make it bigger. Okay. So let's put it right... Whoop, 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 whoop. Right here. Come on. Let's make it 5. By 3? Yeah. So we need 3 more. And another modem. Let's do stone. Regular stone, please. There you are. Redstone. Okay. And I'm thinking what I'll do is I'll let you guys make this monitor and make it as cool as possible, because I know a lot of you guys are more creative than I when it comes to design. And I'm going to try and see if I can get the Open Peripherals terminal glasses to work, so that not only do I have it displayed here, but I can also wear the terminal glasses and see it from anywhere in my base. I hope that works. I think it would be cool. But yeah, there you go. So basically, again, to reiterate, you guys have a 5x3 space to work with. You can set the font scale smaller if you need more space. And we want to see 8 different engines, their current energy, what it is, and then if they're on or off. And then somehow color coded so I know which engines are which. And again, the code for my existing program down here will be in the description. I think that's going to do it for today's episode, guys. We got the oxygen turned on. Again, comment if you got what ways I can improve this oxygen network. I don't know if there's a way to kind of hide these bubbles or something, because I don't really like them. They just get in the way. And then also, please work on that monitor program if you're a computer craft inclined, if you're good at that kind of thing. Other than that, it's been FunshineX for Feed the Beast Unleashed in space. Say goodbye, little Funshine. No, he's not going to do it. All right, we'll talk to you later. Bye.